Key IP-based protocols. Now, there is a big difference between the communication, which is unicast, multicast, broadcast, and anycast of IP, and the protocols of IP, which is primarily TCP, UDP, and ICMP. Now, I want to make sure we're all on the same page with something before I go any further. You and I do not choose these protocols. We don't choose the communication type that happens. This is all for an application developer, right? Somebody out there is programming applications for the computers. Let's just say it's an online game developer. Maybe he's making World of Warcraft, right? Actually, let me use a game I know, Counter-Strike. I never sold my soul to World of Warcraft. So Counter-Strike, old-fashioned game where you just, you pick it up, you shoot some people, and you're done with it, right? As an application developer, I want to worry about the programming of the sprites and the weapons and how the people move and all of that. I don't want to have to worry about, well, if a packet gets dropped between the Counter-Strike, client and the server, well, we have to retransmit. No. I just want somebody I want to delegate that, right? We'll use a management term. I want to delegate all of that to something else. And the something else are these different protocols that are there. The most popular one is TCP. So as an application developer, you can program your application to use TCP to communicate. And there's a reason it's called TCP IP. That's how common it is. It's almost always paired together. TCP is a reliable method of communicating between two endpoints. And what do I mean? Well, an online game probably isn't the best way to demonstrate that. Let's just say that I'm going to an online bank, right? And I'm transferring $100 from my checking to my savings account, right? So I'm on the application, which would be at that point, Chrome or Edge or Firefox or something. I'm sitting in there and I type in $100 and I say, okay, transfer, here's the transfer button, click, you click that. What happens? Well, that guy sends a message over to the online banking server saying, yes, I want to transfer that $100. If I'm using TCP, this guy always sends back an acknowledgement saying, I got it. And that's a good thing because we want to make sure that when we transfer that $100, that's received, at least from the network perspective, and now it's up to the database and all of the coding in the application to make sure that $100 gets from one account to the other, right? Reliable network communication is what TCP is all about. Now, UDP, on the other hand, is unreliable communication, which I know you're like, why would you do that? If you have TCP at your disposal, why would you want to rely on something that's unreliable? Well, because there's a lot of real-time communication that happens out there in the world. See, the way TCP works is when this guy sends that $100 transfer, if it doesn't get that acknowledgement back that says, I got it, this guy's going to resend the message and resend the message and resend the message until it gets that acknowledgement message back, or it says, well, the network is down and you get the failure message that displays on the screen. That's how it works. Well, what about if I'm sitting on Skype? Right? Having a voice conversation with somebody overseas, right? And I'm talking on the phone just like I'm talking to you right now. And I'm like, yeah, yesterday, I went to the store. And let's just say every word was a packet. It's actually much smaller than that, but we'll go with it, right? So I said, I went to the store, right? And all of a sudden, something happened in the cloud. There was some congestion and the word to ended up getting dropped. Is there any use in Skype going, oh, I didn't get an ACK for that word. There was no ACK. Let me send that later. No, it's real time. It happened, right? I said, I went, there's a blank in there. I went to the store. You don't want it to go to at some random point later on in the conversation, right? So real-time communication, so real-time voice, real-time video, or that online game. There you go, that Counter-Strike. I don't want to have my little guy sitting behind a wall, getting ready to pounce on somebody that's coming around the corner, and I was, pushing my little up arrow on my keyboard, and it's recording up, it's sending all these messages to the server up, and 4 of them, let's just say, drop. I don't want at a later time those to be retransmitted and my guy shoots out from behind the wall and I'm like, I get shot because it's all real time. So you get the idea, right? This is communication it's just happening. It's not impacting anything in a real-time fashion. And matter of fact, you don't want the overhead that's associated with keeping everything in sync and making sure everything was received when you're talking about things like real-time communication. UDP is always used. Now, this guy down here is one that only network engineers would typically know about. Actually, no, come on. Your grandmother does not know about these things. So I guess all of these are network engineers, but let me say these are things that network engineers typically use. ICMP, Internet Control Message Protocol. Think about that phrase, Internet Control Message Protocol, right? Just think about how that sounds. This is a protocol specifically developed for control messages. The thing that you and I will use this for almost every single time is something called ping. Come on. This is, if there is a Phillips screwdriver in the network engineer's tool belt, this is it. This is where you can come up and say ping 4.2.2.2. There's just an IP address out there. And I can get a reply back and go, okay, it's online. This is such, I think of what would your world be like, Jeremy, without the ping tool, right? And it's the same thing as like somebody saying, how would you exist without a car, right? I'm like, I guess I could walk places. It would just take, exponentially longer to get there. And it's the same thing in the network world. Ping is your tool to test network connectivity. So when I go ping, let me try this, 111, you can see that this IP address is saying, you know what, there's no response coming from that guy, so that one must be done. That's all done using the Internet Control Message Protocol. Technically, there is no ping. There's actually, matrix, there is no ping. Echo. And echo reply is what the two messages that the ping, right? You get what I'm saying? So when I send a ping, it sends an echo to one side and an echo reply comes back. There are other things ICMP does as well. Like when you see those, page could not be displayed or I'm redirected. I mean, ICMP does a lot, but from the network engineer, just remember ping. Now, as I mentioned before, there is a reason they call it TCP IP. TCP is special. And chances are if you're not using real-time communication, you're using TCP to do it because it's the reliable way to communicate. Now, when you hear people describe TCP and UDP, they'll usually say, well, TCP creates a session, whereas UDP just sends it and hopes it gets there. It's very similar to like if you have a relationship. Let's say you and I were to meet on the street, I would probably say, hi, I'm Jeremy. And you would say, oh, well, hi, and you fill in your name. And I'd say, okay, great. Well, let's start talking. We've kind of formed a miniature relationship, or what these computers would be considered a session before we started communicating. Versus UDP would be like somebody walking by on the street, like hitting your shoulder, and they're like, oh, get out of my way. It's like they don't even know if you heard it. They had no relationship with you. Just slung something at you. Probably going to get beat up. But it's just a random way of communicating. That's UDP, right? Just send it and hopes it gets there. That's the difference. So if we're talking about session, relationship, how does that work? How do these guys meet each other? Because if we don't understand this piece and our communication is failing, then we won't be able to really troubleshoot. So the very first message, let's paint the scenario here, right? We've got CBT Nuggets web server. You want to go there and you want to access that content. Before you do, the very first thing that you will send to the CBT Nuggets web server is known as a TCP SYN messages. That's short for a synchronization, SYN. And essentially that's just saying, hi, my name is Bob. I want to talk to you. I want to synchronize with you. CBT Nuggets gets that and says, okay, great. I'm going to send back a SYN ACK message, which in a nutshell, ACK, that's short for acknowledgement, says, okay, great, I got it. I got your communication, and I'm going to synchronize with you. It's like saying, hi, I'm CBT Nuggets, right? This guy comes back and says, oh, okay, great, I received that. Let me just let him know that I received it, ACK, and now we formed a relationship. Yes, I'm going to unpack this a little bit more. That's very, very high level. Yes, this is like meeting each other, but what's really happening behind the scenes? Well, TCP is a reliable protocol, right? Everything that comes from this computer to the server and vice versa should be acknowledged, should be ensured that it got there. So really in the SYN message, what you're sending is a sequence number, meaning I'm going to start sending data. And I'm going to start from the sequence number, let's just say 1000. It's just a number that the operating system of this computer will generate, whatever the last sequence number it left off at is. So it says, I'm going to start from 1000. So this ACK message says, okay, great, I'm going to acknowledge. So inside of here, if you literally took a scalpel and opened up that ACK message, you would see it say, okay, this is ACK 1001, which means I got your 1000. The next thing I expect you to send is 1001. And by the way, the number that I'm going to start sending from is, let's just say 4,000, because based on my communication, the last message, and by the way, these numbers are like 5,622,000,000. Yeah, I mean, these are big, I'm just using big round numbers for right now. So he's like, I'm going to send starting from the number 4,000. And so when this guy's like, okay, got it, what do you think he sends back? 4,001. Right? He's like, oh, okay, great, I got it. So I'm expecting the next thing that you're going to send is 4,001. So now what happens? Well, the very next thing that happens is, let's say CBT Nuggets is like, okay, now that we have this relationship, let me give you the web page, or let me give you the content that you're looking for, right? So what he's going to do is say, okay, let me send you, I'll just say a picture of Jeremy, right, which is sitting on the website. And that picture is, we'll just say 50,000 bytes of data. So I'm going to start from, 4,001 through, 50,402, send you all of this data. This guy receives that data, and I'm getting a little ahead of myself, but I'm hoping you're catching this concept. He receives all of that data, so data goes, and sends back an ACK saying, okay, 54,003. Right? You left off at 54,002. So I'm going to send an ACK for 54,003. So the CBT Nuggets web server is like, sweet, he got the picture of Jeremy. I'm going to keep sending data, starting with, what's the next, some text describing some of the courses we have or something like that, starting from 54,003 and keep sending. But hold the phone for just a second. What if there was a problem? What if somewhere in this cloud was a little Pac-Man monster that ate up some of our... What is that? It's a creature that ate some of our data. And, this picture of Jeremy got halfway there. It got up to like 30,206, whatever my hand writes. It got about that far. And then the Pac-Man creature in the cloud started eating data. It started losing some data. And all of it didn't get here. Well, instead of sending ACK 54003, he's going to go, let me send an ACK for 32564. Right? Because the last thing that I received was 63. This server's like, scratch, hang on. Hold the phone, back it up. You missed some data, so let me back up and resend from 32,564 all the way down to 54,002. Are you getting it? So I know I went beyond. I said I was getting a little ahead of myself. I was just planning on talking about the three-way handshake, but once you open the can, you got to just keep going, right? So that's what these things accomplish. They establish the relationship, but then these sequence numbers are used forevermore during the communication to ensure the data stays in sync. That is such delicious stuff. Okay, one more thing I want to add to this. You ever been doing a data transfer on a Windows computer and seen something like this, like you drag a file to copy across the network, and it's like, oh yeah, just 41,423 days and 22 hours remaining, and you're like, what? You're staring at it. It's like, oh, no, just kidding. Like 5 seconds later, it's like, actually just, 21 days and 11 hours to copy that. And, it's like just enough time for the shock to set in. And you're like, it's absurd. It's like, yeah, actually, no, just kidding. It's just going to be like 6 hours. And by the time it's sent, it's like, yeah, 22 minutes is really all this is going to take. And you're like, what's going on? Well, what you're seeing there is actually the effect of TCP sliding windows behind the scenes. Here's how it works. The computers that are transmitting don't really know how reliable this network is in between. And so what they're thinking is, I don't want to send a whole bunch of stuff just to find out it all gets dropped. So it starts off really small amount of data. It says, hey server, let me try sending this to you. And the server goes, yeah, I got it. Sends this ACK message back to the computer. And it's like, oh, okay, well, that went well. And right about there is where Windows pops up. It's like, well, that was successful. But if we're going to send that little small amount of data and then wait for an ACK to come back every single time, it's going to take 41,200 whatever days to increase or to actually reach the completion, right? So this guy says, well, let me actually send a little bit more data over here to the CBT Nuggets web server. And this guy's like, yep, I absolutely got all of that. I will send my ACK message back to you. ACK, got it. And at that point, Windows is like, oh, actually, that went really well. Let's decrease it, 21 days at that rate. So what happens is the computer keeps sending more and more data at a time for every single acknowledgement that it receives back. So that's what's known as the TCP sliding window. Starts very small amount of data and increases. Actually will increase infinitely to send a huge amount of data. But you know what? Eventually, it's going to hit the ceiling. right? It's going to hit the ceiling on the bandwidth or this router or the switch or something along the chain isn't going to be able to keep up with the amount of data that it's sending. So it's going to drop. And all it takes is one little drop. And that sliding window is like, oh, okay, move the window back down in size. So that's where you start seeing, 41,000 days, 21 days, and then it's dropped down it's like, hey, 11 hours, and then it's like, 16 hours, 11 hours, 15 hours, 12 hours. You'll actually see in Windows, it's bouncing all over the place trying to find that little thing. So maybe, 60 seconds in, it's finally like, okay, it's going to take, 10 hours or whatever, and it stays steady. What it's happened is it's found that sweet spot. That sliding window size where it can send a good amount of data. It knows it's going to get there, and then an acknowledgement comes back saying, I got all of that data. The goal is that you and I would be able to this just popped in my head. I'm going to use this analogy, and I may edit it out in just a minute. Talking to my wife at home, we kind of have this sliding windows sort of relationship. I'll come home, and she's like, "Hey," I'm like, "Hey," and she, although she will increase to a substantial sliding window, let me tell you about it. And I'm kind of, initially I'm receiving, but somewhere it's got to be the cloud, right? It's got to be the cloud in between us. Somewhere in there, like my capacity to receive is like I'm glossing I'm glossing over. And so you've gone past my sliding windows, and she'll probably know that because I stopped sending acknowledgments. And this probably is where the analogy breaks down, because it's not like TCP, because I'm like, and I've lost it, and all of this stuff right here is lost. So she has to back down her sliding window side and resend all of it. That's how sliding windows works. It's just a little more mechanical than relational. Awesome. Well, we have now seen the 3 different communication protocols that exist, and I shouldn't say that exist. There are actually many other ones out there, but the primary protocation, we'll go with that, TCP, UDP, and ICMP used for network communication of today. And then TCP is special. So we had to zone into that a little bit, saw how it formed relationships with its 3-way handshake, exchanging the sequence number, the acknowledgement number, and then use sliding windows to determine how much data it could actually send across the network reliably before drops could actually start happening. I hope this has been informative for you, and I'd like to thank you for viewing.